having done tug of war on dirt before, sometimes you slide, sometimes you're walking. So whether it's static or kinetic depends upon what's physically going on there at the feet.
So I have a ramp and I have a mass that's 5 kilograms, and there's an angle 35 degrees, and it's asking the acceleration.
All right, so in the case of box on ramp, if it starts at rest, you first have to, you assume it's not moving and you use the static. Is the downward force enough to overcome the static? If the static friction. If it is, then it is moving, then so you plug in the kinetic values. If it's not, then the acceleration would be 0.
For the kinetic?
For box on ramp.
Okay.
In the case right here, I guess conceivably one side could be static because they're walking backwards and their feet aren't slipping, and the other side is holding firm and their feet are slipping. So the other side could be kinetic. Yeah, that'd have to be a carefully worded problem if I wanted to bring that into this.
Yeah, so when you were trying to get acceleration, like why did you combine the equations? Like couldn't you just have found it by like just doing it straight up?
What we are given is this force that they're exerting, what we're calling friction here. They give us the 1365 and they give us the mass. We don't know at this point the acceleration or the tension. So we have 2 unknowns, so we have to bring in a second equation somewhere.
Okay.
And so this is a second equation with the same unknowns.
What if like the tensions didn't cancel out and like you would have like 4 unknowns, and like what would you do?
We'd have to have another relationship. The problem is where I've done where the tension does not cancel out. That would be a situation, where there would be a component of the tension that is trying to keep this from moving down the ramp, and a component of the tension that's actually trying to lift it up off the ramp. So that would be a situation there where I'd have to give you another piece of information, the angle, and you still have 2 equations, 2 unknowns, it's just not as simple. So mathematically, if you had 0.5, I'll just do t for simplicity's sake, minus 3 is equal to 7a, and 6 minus t is equal to 3a. In a case like that, when you're trying to solve it, it depends on your technique. I could just multiply everything in the first equation by 2 in this particular case, and now they would cancel out. Or I could just solve for t and plug into here, or solve for that t and plug into here, or solve for a and plug into the other one. There's a slew of techniques that they would have done in algebra 2, both to solve it.
Okay, so yeah, that's just the system of equations. That's
Yes.
Yeah. Okay.
Yes.
That looks fun, but it's like I was thinking about it too deeply. It's just a system.
Yeah. So once we get into this, once we get the equations written, it's a math problem.
Okay.
And it stays a math problem until you get to the answer, and then you have to say, oh, this is physics, this has some meaning.
And if we would have had tension, then we wouldn't have to like combine them. Like we could just plug it into one of them. Like
If we had no tension already,
yeah, we could just
Yeah.
do only one.
yeah, they could have just as easily asked us to find tension first and then asked us to find acceleration.
Okay.
Ben?
Is MS, MK, and US, UK are the same thing?
MS and MK, depends upon, that almost looks like, depending on how it's written. Alright, so this letter, this is a mu.
Ah, that's not M?
It's not an M, it's a mu.
Okay.
Sometimes when I'm writing in a hurry, it looks like an M, but it's not supposed to be an M.
And also, when is the test corrections due?
Generally, it's 2 weeks after, maybe the 22nd is the target date. And again, if you're not ready on the 22nd and still gonna do it, just let me know when I'm gonna see it. So it's not a hard and fast date, it's just something I'd like you to target.
What is mu a unit of again?
The units,
Yeah.
it's unitless.
Right, but like mu comes into play when we're talking about. Is it there? Okay, thank you.
Yep, that kinetic friction is equal to the coefficient of kinetic friction times the normal force. And then the static friction is less than or equal to the static coefficient times the normal force.
Okay.
And the textbook writes I think they use a capital N for normal force, or the book writes it slightly differently, and so at the top of the quiz or test, I think I have it written down so that it's the way the book writes it and the way that I write it.
Okay, so there's like mu, and then there's like a capital M too, so it's like, is
Yeah.
that how the book does it?
I think so.
Okay, that's a little confusing. I'm glad you do it with the Y.
Yeah, well, no sense ranking now. That was my ranting. If you want to rant, go for it. Other questions right now? All right, so let's pick up on centripetal.